Yeah, here's my, thank you, Jason, for the introduction. I think the topic today is how to operationalize a machine learning pipeline. And this is based on my observation on the current state of AI ML. Data scientists and the machine learning practitioners usually start with a notebook to build and test and deploy ML models. But they also needed to ensure they perform these tasks in a reliable and flexible and automated fashion. So in this presentation, we'll walk through an MLOps pipeline, which running Amazon AWS to automate the typical procedures used by the ML practitioners. Essentially, we will automate those manual processes such as data pre-processing, feature engineering, model training and testing and deployment, and also monitoring. We're going to do this in a CI/CD pipeline. This is using the Agile DevOps best practice. It is a shop learning exercises which I done months ago, and then I extended that workshop content into this presentation. So some of this learning I can share with you of my observation, and also I'd like to hear your experience and questions on this topic. We'll first look at some Amazon machine learning journey with their AI ML stack, and then I'll share a couple machine learning operation use cases, which you can see the variety of different type of requirements for MLOps. So from there, we'll talk about why we have this such a big hot topic in 2021, and I'll give us a little bit of introduction for the tooling on CI/CD, because even some of nowadays there are many tools running CI/CD process, both on AWS, open source, or others choices. Then we'll go through the code pipeline, and then we'll finish with some summary of the process and discuss some takeaways. I had a presentation last year with ideas to talk about the machine learning stack on Amazon cloud, particularly on AWS. These are the, when you talk to data scientists or machine learning practitioners, these are the AWS message they try to deliver. These are the tools you're supposed to use, and different layers of stacks. They cover a variety of user experiences and the toolings. But this machine learning stack actually did not address the two issues. One is how do you create and improve organization culture and agility for CI, continuous integration and continuous delivery? Because this is not just the Amazon way. I think if you look at the other cloud vendors and most of the big players, they talk about the machine learning in this fashion, but they don't have integrated the story with CI/CD. The other thing is how do you create an automated infrastructure to support your process, to operationalize your ML model? And think about the services and tools we see on this chart, probably like 30, 50 services. Even with these rich, broad services, it doesn't give you all the capabilities to automate your machine learning. And the challenge, I think, they from, because from data scientist perspective, you're not seeing the side of the story. I think that's usually where I was coming from, and now I can start to appreciate why we need a CI/CD. So I'll start with 3 use cases for machine learning operation. When I say machine learning, Jason, can you? I just want to make sure people. Okay, I'll continue. So if you see the use cases here, is the first use case is the requirement is how do I create a containerized machine learning model to monitor them and automate them. It involved a different type of tool sets, including containers and Kubernetes. You look at the middle one, for that machine learning system, the focus is try to create a serverless model monitoring and automation pipeline with a different focus than the first one, right? Because the first one, you build everything from ground up. The second one, you actually use this as a serverless manner. If you look at the third one, which is model governance and automation, the focus over here is actually try to create something totally customized. Customized is you are not necessarily using the tool sets from Amazon AWS, from CI/CD perspective, and also from machine learning perspective. So that gave us a good understanding to create a machine learning operation pipeline. It's really based on requirement, and the requirement come from system design perspective and the software development lifecycle perspective, on top of develop a machine learning model, train a machine learning model based on data, which is the core of the AI and ML. Unfortunately, my current understanding is there's no cookbook to have one size fits all. But at least through today's presentation, I hope I can give you a little more insight than how we can have a good understanding of the core component, at least to fulfill those gaps. So let me get to the next slide. So why now? So machine learning operation, the definition is active management productionized model, and its tasks, including the stability and the effectiveness. So machine learning operation is really about how to maintain the functions of the application through better data and better data, model, and development operation. So simply put is how to operationalize the model, how to operationalize the data, and how to operationalize the development. So here we have both good news and bad news in 2021. Studies suggest between 85 to 96% of the to production. So low in terms of from POC going to production. And then Andrew Ng recently had a good tech talk on how to shift people's mindset from algorithm-centric to data-centric for machine learning. And from his experience, he said, try to put more time and effort to get data into a better shape, then we'll see better investment return than take the latest state-of-the-art algorithms. Algorithm is still very important, but data is actually more harder problem in today's world. Yeah, so I guess that's somewhat the bad news, but I think the good news is there quite a bit of advancement in modernizing the data and data analytics in terms of both tooling and the methodologies. And also there are more cloud and cloud native best practices. We're seeing more agility in terms of modernized application, including containers and Kubernetes, and powered by latest AI research, such as machine learning, deep learning in NLP and computer vision and such. So before I get to the topic on the pipeline, I want to introduce a couple concepts. You may know this already, but if you just a data scientist, or even DevOps, you may not know familiar with the toolings by AWS. I think nowadays portfolios of product and service offers from Amazon or AWS. Not everybody knows all this tooling until you really need to look into one of those. So DevOps. So first of all, the concept of DevOps is a combination of cultural philosophies and practices and toolings to increase organization's ability to deliver application service at a high velocity. So meaning that these tooling are trying to achieve a quick start and less infrastructure focused effort. You can use managed service on cloud platform, and you can scale it up, and it's also programmable. So if you look at the 4 buckets on the chart, the first one we call AWS code pipeline. If you've been in software development, that means it's a software release workflow. Give you a capability to run, build, test, and deploy. And this is pipeline. This is not just a generic term, it's a product service term called AWS code pipeline. And this one is going to be our core engine today to drive the CI/CD. If there's one key thing as a takeaway today you leave from this presentation, you probably want to write this down, code pipeline. And this is a service offered by AWS. The second one is called code build. In code build here is how to combine the source code and run tests and produce a software package for deployment. And you'll see how we use this to create a different component to support the code pipeline. And then we also have another 2 services called code deploy, which is to help you to automate the deployment into Amazon ecosystem, including EC2 instances, and also you can deploy this code into on-prem servers. The last one is called Amazon code commit. If you know, if you see my show you the pipeline later on, you will understand that the code commit is really a private Git host, GitHub, private GitHub, hosting the source code. So let's take a look at the pipeline. So I'm giving you a scenario just like this, but you can look at this on the left side. To complete this in the pipeline, you actually involve multiple people. You see on the right, this scenario, on the left, you have a data scientist and machine learning practitioners. Their focus is to try to train a machine learning model. And this is usually how people get started. They start, for of Python code to the model, deployed it here into a endpoint. But that actually is not the way you finish. In fact, that's not supposed to be the way you start. So this is just give you a scenario, very high level. We want this pipeline to cover, other than the data scientist to train model, you also want to have a SageMaker to integrate with the code commit, which is the model assets. I'll explain this into further details because we mentioned code commit before. And then we have to have a code pipeline to orchestrate all the services or assets to train this model and deploy the model. And this is at the end. But in between here, we also have a code build, which means we're going to create containers. The containers will help us to keep a copy of all these training and inferencing assets together and put it into a private repository called the Container Image Repository, ECR, on AWS, Amazon AWS cloud. So this is basically what we try to do. There's more details than this, but this is a high level in terms of the roles that data scientists and machine learning practitioner usually use SageMaker to do this. But looks like we are going to need data engineers somehow between this bucket and this bucket. And we also need DevOps definitely between this bucket to this bucket and to this bucket. And if there's other application codes like front-end and back-end integration, then there'll be SDE involved. And if you look at the deployment process, you'll also have a release manager, product manager, business owners to approve the deployment process. So this is the high-level scenario we're going to cover. There are 4 major steps. So I'll go for this quickly. You don't need to remember the details. You just need to kind of get a feeling, understanding, what type of tooling and the process will look like. To start off, for this process, is actually created the repository, creates the placeholders for data, and also for code. So to start out, actually 3 things here. If you look at on this here, if you're familiar with Amazon AWS, the bucket means S3 bucket. So initially, we were going to create 3 things. One is called a data store for the CI/CD pipeline. That is the S3 bucket to keep the raw data and pre-process the training data. And that data, if you feed the data in, it will automatically trigger the CI/CD pipeline. And also, we'll keep also the code. The code over here is also for us to store like the machine learning Python code, system test code, ETL, script and such. And yeah, that is in the code commit repository. And then we also have containers. So you may not get a very clear sense of how these things working together, but just bear in mind that this is how we start with. And we will have this environment created for the assets. So first we create a repository, and that's here. And the next step 2 is we're going to have the assets. When we say assets, that means that the code and the component and itself. So let me be more specific. What do you mean assets? So the assets can be ETL assets. The ETL assets can be the Python code to do the feature engineering, to split the raw data. It can be the configuration files for your ETL jobs like JSON files. It can be Amazon ETL service like Glue, the Python shell configuration files. It can be different way to do it. It can be native shell script. You can use also like SDK, but that's that's one type of pipeline assets called ETL assets. The second assets can be, as I mentioned previously, the container image. The container image will keep the copy of all the model files, the API endpoints files, maybe your web server configuration files, and maybe the CloudFormation scripts, and maybe Docker files, and things like that to containerize your training files. Then you also have system test files. How do you run system test scripts? Essentially, step one gives you a repository to store your assets. Step two, you create the assets. You keep these assets in these containers, S3 buckets, and the code commit repositories. So right now we are preparing the pipeline. Now we are executing it. When we say we're executing it, you may not see this very clearly, but I have these are actually step-by-step execution. It's going to run probably a couple hours, depends on, with this exercise, this is not big job, but in production, this job can be, can take hours, can take minutes, depends on your requirement. But the process is pretty much like the same. They have detailed step-by-step orchestration using this pipeline to drive through the deployment. And I'll have the process flow once I finish the review on this part. So you'll have another time to review this. So over here, actually, there are two things worth to mention. One is we use something called automation, called code as infrastructure, called CloudFormation. So basically, we use scripts to deploy the resources for this pipeline and then kicking off the pipeline for running. And the second piece is, again, we call this pipeline execution. And this pipeline code commit, code deploy is all through, you can do all this through AWS console, and you can also somehow script it. But for this exercise that I'm showing the console, and some of them I'm doing with the CLI command line. So this is the final step. After you create and execute the pipeline, you actually deploy the model into production. You first actually do unit test, which is a part of the pipeline, and then you do system test, which is also part of the pipeline. Once the system test passed, then you're going to get someone approve this into production. So once it get into the production, then you're managing the operation in production environment by monitoring. There are two pieces here kind of worth to mention. One is we want to monitor the serving side, because the model trained and deployed, you're using the endpoint or inferencing through that endpoint to run predictions. And then that is done by monitoring the infrastructure scalability in terms of the load. Say suddenly you have a lot of data, you have some criteria to scale this up for inferencing metrics quickly. Maybe you need more containers, more EC2s. The other thing is monitoring the model. You want to see the data quality and model quality, and that is a different type of metrics. It traditionally can be hard. If you may not pay attention to my the first ML example slide, the third slide, third scenario, people do model governance. Initially, in that use case, people using Excel spreadsheet to keeping track of this model metrics. because they don't have a way to do it. Eventually, they use, I think it's a Databricks, the ML flow. They use that ML flow to achieve that. But here, using this pipeline, you're able to do this end-to-end to monitor that. Again, coming to all these decision point, it's also tricky, and maybe that's another big conversation and discussion. So if you remember, I gave you the scenarios. I have like 4 boxes or something. You think there are like 4 steps, but really here I extended this a little bit. Now there are 12 steps. So if you continue to drill into the details, you'll find out there are more gaps, more customization you can do or you may have to do. So if I go for the step 1 here, say, how do you trigger the pipeline? The trigger can be 3 things. I say 1 is you have a new data. In fact, 2 things in number 1. Either you have a new data file or you have an updated data file. Somehow you have to detect it and then trigger, use as trigger to trigger. Secondly, it can be a source code change. It can be either the model Python code or maybe your glue job to run ETL in code commit. So, if you think about it from traditional data scientist perspective, you only think about the, hey, I have a streaming data coming in, and I have new data, then I'm going to trigger a pipeline. But it depends on the scenario. You may have to trigger the pipeline for different reasons, for different purpose. You look at the second one, it's also the this one on the left. You actually introduce another services which we never mentioned before. It's called Lambda, and this one actually triggered the ETL job. I mean, you don't go there, launch this job, the Lambda will detect it and see when and how to run this one. That's number 3. Number 4 is also a trigger. That trigger is once the ETL job completed, the code pipeline will call another Lambda function to start a model training job. Because the pipeline already know that first you need to finish the ETL job. And once the ETL job finish, I'm going to start a job for SageMaker training job. And you see also we have a CloudWatch events over here to monitoring this training job. If the training job failed, what do you do, right? And so that's number 5. The CloudWatch to see if the training job succeeded or not. If the training job did not finish successfully, I had to do something. And the report's final status back to the pipeline. The pipeline need to know what to do at that point. So that's number 5. And number 6, so based on the model training result, if it failed, it will stop. But if it stops, people had to get into there and find out why it failed, why it stopped. Alternatively, if things running fine, then you'll proceed to step 7, which is deploy that endpoint for SageMaker. So we're on step 7 now. The step 7 is actually the first environment we deploy the endpoint, which is our QA environment or development environment. You can have multiple environments. This is a simplified version. I have 1 environment. It's a simple endpoint. Maybe it's a small EC2 or cluster. But when you go for production, then you have a sizing problem, which we had to talk about on step 9 or step 10. So now we go to step 8. The step 8 is wait for the cloud formation, because now we have the pipeline finished deployed into QA environment, we need to reallocate the production resources to train and deploy. So that is number 8, which is you use CloudFormation stack. I think I'm on step 9. Yeah, I'm going to skip a little bit. Ultimately, you're going to go to step 11. In step 11, you're going to have auto scaling based on certain criteria. You're going to just recreate another endpoint, which is your production environment. And step 12 is ultimately the execution will finish. So if you see the code commit start here, but this is the code pipeline all the way down to 12, right? But you need additional support and services to make sure the real job running from ETL, training, and towards the production scaling. So this is the orchestration process, help you to monitor and drive these, key processes and services for machine learning. So I think that's a quick overview of, let me see if I have any questions people want to ask at this point, because I probably can finish this quickly and a little quicker than I expected. So at the end of the day, we see machine learning operation in version 1, we actually focus on manually build, train, and tune and deploy model. I think machine learning version 2 come to the time is we still manually build, but we kind of orchestrate this pipeline. The step we're showing here, we kind of can do it manually. But at the machine learning operation version 3, which is currently we see somehow using CI/CD, we can do this in an automatic fashion. That includes the monitoring service, the trigger using Lambda, and also the logical condition to understand the orchestration condition and the criteria to go through stage between QA to production. So to summarize, machine learning AI is really not just about data, but also code with data. And we should try to look at it's not saying we are not going to be model focused, but we need to also look at the data, how to see the data change. And based on that data, then we'll have different quality of the model. And from that quality of the model, we have to feed back into the beginning of this pipeline. One of the observations, I think people are actually, I was listening to Andrew Ying's tech talk about this machine learning operation and the machine learning pipeline. He's asking the question, who you think will be ultimately the owner of take more responsibility to own this pipeline? And I think for that audience, mostly data scientists. But I think it's still very debatable who will be driving that. I think there's a bigger part of it is going to be the DevOps people, because you are actually taking a lot of different components and services together. And right now, I think the person who can do that job probably is a data engineer or a DevOps person to build the containers, to deploy the services, to deploy the code, run source code control, things like that. That's why I think that the data scientist model training job will be a beginning part of this pipeline and continue to be very important. But to get this pipeline towards the end, you do need a DevOps. And that DevOps process is not just a human being, right? I said it's the culture, is philosophy is called practice, how to do things in an automatic fashion, and in a reproducible fashion. And the other discussion along with how to make this pipeline, because if you get garbage in and then you get the garbage out, and because the pipeline, the goal to create a pipeline is try to see, I have a model maintenance for performance and quality, and that quality is based on data, and the data should be shifting from big data to good data, and I think even for big internet company, they have big data, small, they still have a good data challenge because there's a lot of long tail real cases still need a big data or more data. So creating that good data is continue to be important. I mean, I try to mention this because to make MLOps working effectively, you need a good data ops, dev ops, and also data ops, dev ops, right? There's another way to do this. Today, I only show how to do this using the Amazon services. There are other third-party and open source tools to achieve something equivalent, and maybe in certain circumstances can be better. But the core component I illustrated over here are kind of generic, still need to be, evaluated at least to understand, do you need it? Should you choose the right tool to achieve that same outcome? Yeah, so I think that there's we're still in the early stage of this. That's why this has become a big pinpoint today, because we're coming to the time that we are probably very close to get AI into production in more environments, and we're coming very close to it. And we still have this challenge to simplify this process to get this done in a more effective or reproducible manner. And that's how I, come with the motivation to look into this topic. I think without further ado, that's I think that's all my presentations in 45 minutes. If you have any questions, I'll be happy to discuss with you.
Thank you, Andrew, for giving us a speech. I saw 3 questions in the Q&A session.
Okay.
Can you answer that?
Okay, let me see if I can see it. All right. So the first question, can I know if there's a big difference between the major cloud providers like Azure versus AWS? If I want to deploy some models on the cloud, which one is better? I know it might be a long question, but would you make a relative? Actually, let me put Azure at the side. I know that Google recently launched the machine learning auto ML platform, and it is kind of like a SageMaker. But if you think about the way we can do this pipeline, let me go back to that slide. The way we can do that pipeline effectively, successfully, is because we have the SageMaker component to begin with. Because these are the machine learning core services. Without this, there's no meat for the story, right? So I think that for a cloud vendor to provide a robust, scalable, extendable pipeline foundational services, you need these level details. And that is why, Amazon Cloud, I could be biased, claim they have a broader service offers. So if you look at the SageMaker, the details of the capability is vast, means that the APIs, SDKs, and services are already there. It's time to use it and leverage it with others. So go back to your question, the cloud vendor for Azure. I'm not familiar with them, but I know they also have a very much similar machine learning stack. I'm sure they also have the like a DevOps services and stack. I guess you just have to try and see, do what I do, find out if they have a good reference architecture, design pattern, or workshop, and see and compare what they do with mine, and see did they achieve something I didn't do. And I'm not saying this is the most comprehensive, but I think this is a little bit more than a regular, normal, small team can develop and build up from scratch, right? So I think you should still looking for vendors for services and options. Yeah, so that's the same as the second question. I cannot make a good comparison. Maybe Azure service is better than Amazon's. It could be possible. But I also want to comment on, go back to my scenario, these scenarios, right? If you look at these scenarios, you're talking about the scenarios beyond what I showed. That can be other infrastructure component and services, maybe Kubernetes services or container services. Maybe you want to build a customized feature store using a database. Whether you can use third-party machine learning pipelines like MLflow. The MLflow is pretty much like the SageMaker plus code pipeline together. They have overlaps, and you could be using Jenkins, right? So I think what I mean is when you have a bigger environment, then your requirement can be very complex. Depends on your governance model. So what I mean is you end up making a choice probably beyond the tooling level at individual services. You have to look at the overall capability for pretty much like an end-to-end process, right? Yeah, this 12 steps workflow used as multiple. Yeah, definitely there are multiple. Let me show you one more time. You can understand a little bit better. I actually appreciate you ask the question and because I was doing this pretty fast. So if you look at these steps, just preparing assets, these are all done automatically, right? So preparing all these configuration file, JSON file, Python file, YAML file, Lambda file. Yeah, they take a Docker file. So all these the good amount of automation is preparation, right? It's a design. You have to design this pipeline in a way that fulfill all these requirements in an automated fashion and scalable way, right? So I think that's one piece of code. The other piece of code over here, not the other piece, multiple pieces of code is this is done by the orchestration pipeline as a services. You click a button, this is running through in a matter of hours. So each job can be a configuration and CloudFormation stack combination with scripts. And yeah, so I guess I'm not sure if that's exactly your question, but the code itself is a much vaster, much bigger in terms of the landscape, bigger than I could imagine to begin with before I did this. But if you find a good tooling, and a lot of vendors and the small companies, startups are trying to address issues in this space, they probably give you a more automated out-of-box solutions. But but you get locked into if you're not able to do customization there potentially. But maybe that's what you only need. But again, I think even Andrew Ng, he personally admitted right now this is still in very early stage. I don't think there's a one size fit all. You'll find one company give you out-of-box solution. You can do something pretty quickly, pretty easily, and without worrying that your requirement change, 6 months or 12 months down the road. But the learning path is pick a platform, experiment with the key, if I say the 4 building blocks is, prepare your assets, prepare your repository, create a, generic key pipeline, adding monitoring, define the different stage, define the workflow process to approve, reject, and detect, and then also have the productionized capability to, do scaling, do data drift, and monitoring, things like that. So I think that's all important. Let me see. Be some other questions here. Sorry, I was not able to read very pretty good. Let me see if I missed anything. If we use C++, I think those code is in Git, in the private Git. You can just those are generic code repository, so it should be okay. Can we please suggest in the pipeline where model validation can be integrated, including concept validation? Yeah, you can do you can do this in a testing phase. You can do that in production phase. Once you get model trained, you probably can put it in. I think this is a generic pipeline, and everybody can, depends on your governance model, because usually it's because defined by governance model. If you are allowed to do that, then you are in the stage of having that data points, then you can do it. But if you don't have permission, you are not giving the access to do it, you have to wait to the next step, whoever pick it up. Why we use Lambda? What's the logic behind this choice? I think this is a trigger, right? It's a condition trigger, and it's pretty lightweighted. You don't need another very heavy, complex service to do that, or code. And you can schedule it too, right? I guess, again, I think my understanding is you can do other way if you want. But that is logically, I think that's easy to understand, because Amazon always suggests their what do you call the best practice design pattern. They will use what they think logically the easiest, quickest way to achieve the same outcome. It doesn't mean that you have to use that, and depends on your requirement. Sometimes you have to choose something more sophisticated, or maybe more linear. Maybe you want to write your own script without using Lambda at all. So that's also doable too. The learning AWS deployment. Yeah, actually, for me, it's pretty hard to learn deployment, because if you don't do this day by day, you only learn a small percentage, because you don't run into the problems, issues like a DevOps person. And that's my argument. I don't think a data scientist can easily take on this job, because the skill set is completely different. And the people doing this type of work are like 15, 20 years, they're used to it. And they just need to learn the web, the services. The practice is kind of still consistent. But learning it, yeah, as I mentioned, you pick up you should pick up a group of services and chain them together rather than in learning one. Meaning, you can learn pipeline, but maybe, what worked better together with pipeline, right? Code pipeline. Why do about 90% AI projects fail to be deployed as production? Because it's hard, right? Because you see this process is pretty hard. If you never get into production, they never get into production, right? Because the data scientist doesn't, number one, don't have that permission or a skill set to push that and get this automated. And if you look at my use case 3 before, which is because what? Why they fail? They fail because a retail company want to improve working practices of their data science team. Their machine learning development lifecycle process was manual, causing avoidable human errors, introducing inconsistencies, slowing down the model development lifecycle. So in any case, you are doing very much manual work and it's not reproducible. And then you can imagine that nobody trusts your work, right? If the model won't change very frequently due to data or code or algorithm, it is not really necessary to use the code pipeline. Yeah, and the complex process flow, right? Yes, team can also update. Yeah, I also agree with you that what is the best design pattern? The best design pattern is the best fit. You don't necessarily have to use the vendor's best practice or best design pattern. If your job can be very linear, you don't even need to use SageMaker product alone. Maybe you use a very small percentage of it. You can use another vendor's product on EC2, right? So yeah, it's one of the biggest challenges nowadays. You use AWS is you have so many services and nobody can keep it up. So you have to be very focused on learning what you're good at. And that's my other argument. You're not going to have time to learn data science in addition to learning DevOps, learn security and infrastructure at the same time, right? So can I customize the code for the steps and send it to the workflow? Yeah. So the process here is really create a template example, and you will have an opportunity to learn from the baseline and customize it. Yeah, I mean, if you look at the code, the commit and the core over here is actually Git. So I think that if you boil down everything at the end is Docker, is EC2, is serverless, is GitHub. If you know all these components, you can learn all these services high level quickly. What I mean for DevOps perspective, those are core skill sets. And the service code pipeline, code commit, code deploy, you can learn this in a number of days. It just gets you started quickly. But once you totally understand the process, maybe in 18 months, you want to write the code yourself. But if you left, somebody else in your team need to pick up your code. And that's your boss, your manager's concern. It's not your concern probably. So that's another discussion point, the trade-off choosing different design pattern and tools.